Assalamu alaikum. My name is Muhammad Faisal Maqsood, and today I will discuss about spectroscopy. What is spectroscopy? The basic definition of spectroscopy is that it is a science which studies the interaction of radiation with matter, the study of molecular structure and dynamics through the absorption, emission, and scattering of light. What is electromagnetic radiation? Visible light that comes from your lamp and radio waves from your radio station. Example, radio waves, microwaves, IR, visible, ultraviolet, X-ray and gamma ray. These all are electromagnetic radiations. So what is the nature of light? The nature of light, electromagnetic radiation, is viewed as both as a wave and a particle wave. And this is called the wave particle duality because this is like wave and also particle. So that's why it's called wave particle duality. Understanding the nature of light. Light is composed of particles. Light is wave. General concept of wave: wavelength, frequency, velocity, amplitude. And properties of wave: diffraction and coherent radiation, transmission and dispersion, refraction, Snell's law, black body radiation and photoelectric effect, wave particle duality, interaction between electromagnetic radiation and matter for spectroscopy, scattering, absorption, and emission. So here is the glass prism. Light is a straight line. Light travels in a straight line. So here in the image we can see the light comes from a hole and this is straight line. The Thomas Young's experiment that has been performed in 1801, interference phenomena. Light is a wave. What is a wave? Harmonic wave, frequency or wavelength. So here is the frequency. Frequency V is equals to C over lambda. C is the velocity and lambda is the wavelength. Wave parameters. The amplitude of the sinusoidal wave is shown as the length of the electric vector at a maximum in the wave. The time in seconds required for passage of successive maxima or minima through a fixed point in space is called the period P of the radiation. The frequency V is the number of oscillations of the field that occur per second and is equal to L over P. Another parameter of interest is the wavelength lambda, which is the linear distance between any two equivalent points on successive wave. Electromagnetic energy. Light is composed of particles, photons. E is equals to HF is equal to Hc over lambda. So here is H is equal to 6.626 10 raised to minus 34 joule per second. That is the Planck constant. Photon energy unit is eV, and energy gained by one electron when accelerated by a potential difference of 1 volt. eV is equals to 1.6 into 10 raised to minus 19 coulomb multiply 1 volt is equals to 1.10 raised to minus 19 joule when light strikes matter. So here are the situations when light strikes matter: transmission, absorption, reflection, refraction, interference, and scattering. These are all the situations when light strikes the matter. Excitation methods: EM radiation, spark, discharge, arc, particle bombardment, electron science, and Camilo. So our next slide is excitation methods. We have four excitation methods: EM radiation, spark, discharge, arc, particle bombardment, and the fourth one is exothermic chemical reaction generates excited products. The next slide I have absorption spectra. Absorption spectra plot of absorbance versus wavelength called absorption spectra. The next and last one is emission spectra. Emission spectra plot of emission intensity versus wavelength called emission spectrum.